we're going to look into the introduction and how to create, store, and access data. For today, been a while since I recorded a video, let's say last month, where the last video I recorded was on a robot. It's just like doing a demo of how the bot was working, a scraping bot, of course. But the last video I recorded on Git was last year, which is very unfortunate. So I intend to do things differently this time round, to like recording this series continuously without delays in between, so that you guys can have can follow up quite happily. So that's it. And also, just to mention a few things of what we intend to do going forward. I intend to record more videos on different topics, and I think that is something that we'll talk about going to the future. Now, right into today's work. Before we begin, I'd wish to apologize if you can hear some noise around. I understand that where I stay, there's a lot of activities going on, but nonetheless, I want to hope that you can hear me loud and clear, and everything is fine. So I've also tried my best to ensure that the quality of this video keeps on improving from the previous videos I recorded, and you should be finding learning quite more comfortable than before. So just also another thing to by the way, if you're following this video right now and you don't have any basics on Git basics, and Git postline commands, those are the normal commands every user should not be able to use Git. Please go back and watch the videos that I recorded before, or get some material and read whichever way you're comfortable. And so today we're looking at the Git internals, or what we call the clumping commands. These are advanced commands. If you want to be a pro, to really get to know how Git works internally, then this is the right area for you. If you just want to like have an idea too, it's not bad. If you just want to watch through and you don't intend to do anything with these commands, but just to have a feel, then you are at the right place. So feel welcome. So before we talked of Git being a content addressable system, and what we said is that Git enables you to save your content into its data store and be able to retrieve it by use of a key. So Git stores data in form of a key value pair, and we talked about hash, the SHA-1, and that is the key that Git generates. So, and which is very important. You have to use that to be able to access your content. So so first of all, the most important thing today is you just mentioned this before, is the Git the Git folder. So when you do the ls, you can't be able to see it, so it is a hidden file. So so to be able to view the hidden file, we run that command lsl, and then we get the Git. So we'll cd into this file. So I've started by creating a Git. I've already initialized a Git file here, and I want us to be able to get the difference between an already initialized and one that already has the tree and branches and stuff like that, and commits, compared to the one that is just fresh. There's a difference between the two, and the difference is with the one that already has got commits and we've already done staging and stuff like that, you'll get an index file, because the index file manages everything to do with staging. But the newly initialized Git folder does not have the index file, not until you do your first staging. That's when it will automatically create one for you. So that's the purpose why I did initialize this before. But what I'll do is I'll delete it, and then we will start afresh. so nothing to worry. By that you'll be able to see the differences between the two. So I'll cd into the .git file and all I want us to see is let's see, and I want us to like, okay, I want us to list all the content within this folder. And as you can see, these are the contents within the folder. First, we have the branches folder, the commits, we have the config, the description, the head, the hook, the index, and the objects. Now, we'll not be covering everything here. The important sections we'll be covering, like the objects, the refs, the index I just mentioned, and yeah, we also have the head, which is important. The config holds the configurations. So just to go through them, and so we also have the index, which because we already have done staging here, but I'll create a new git folder, and you'll be able to I'll do a git init, and you'll be able to see that the git index file will be missing because of lack of any previous staging. All right, so all right, so basically that is it. And maybe just to mention what each of these does. So so there are three things we'll be handling here by the end of this, but we'll break this video into sections. Like the first section only handles the Git objects, and then we also have some, so the content addressable file system will be the first objective, and we'll be handling the Git objects. And then we also be looking at the transport mechanism of a Git, how files are transferred, and how the repositories are being maintained. So those are the three most things we'll be looking at. So we can break these videos into like a series of like 3 videos. So all right, so that is it. And then so you understand that the most important folder when you are creating your Git project is the Git is this Git folder, which is a hidden folder. So if you want to carry all the history and everything about Git, you want to transfer it, then this is the folder for you to like carry. You can transfer it everywhere. You basically have everything to do with Git. Yeah, so it is the heart of Git. If you want to back up your work, this is the file to copy. So so briefly to mention what each of this does. So we have the config file, and what the config file does is it contains the project specific configuration options. That's this. And then we also have like the description. The description is used by the Git web. I'll not talk so much about that, but if you intend to get to know what it does, then you can go and have a read. And then we have the head, and where this is the head, and what it does, it points to the branch you have currently checked out, and I remember mentioning that in the previous video. And then you also have the hooks, and what the hooks does, this one, what it does, it contains the client server side hook scripts. So all the client server scripts are maintained within the hooks. And then we also have the index. I said it contains the staging information. Yeah, and then we also have the objects right here, and the object stores all the content for your database. So I said that Git has got a database of some sort where it stores your stuff. And then we also have the refs, and what the refs does, it stores the pointers. Yeah, it stores the pointers into commit objects. So basically that is it. So we'll be looking into the most important ones, like we look at the objects and the refs and mention, I look at the index and the head. I think those are the most important for now. So that is it with that, and I think we can proceed. Now we can get into the commands. So I'm going to delete this so that you can see that with the freshly initialized Git folder, we don't have the index file for a reason. So I will just clear this and maybe move back, and what I want to do is what about I just like initialize a new file? That's a good idea. So what I'll do is all right, so I'll do git init, let's say, but we'll get back to the, okay, I'll let me do this. Okay, okay, I'll remove this file. Or let me call it git diff. Git new. Okay, so it's created a file called git new. So so if we list, you can see that we have git new somewhere. Here it is. So just to view the contents of git new, so I'll cd into git new. Yeah, then we see the okay, so we have the .git file there, and if I can cd into it and just like get to view the contents of it, let's see. So as you can see, we don't have every other thing that existed in the previous in the previous git folder, because we have not done any sort of staging and commits here. So what we have, the folders are very few. So we also lack the index file, and that was the essence of us creating a new folder right here. So basically that is it. And so the next thing we're going to do is we want to confirm that so for you to be able to like after initializing this, the next thing we want to check that the database does exist and it is empty. And the command for that is we'll use the find command, and then we pass in the path. So we look into the objects. I told you, remember I mentioned, I said that the objects folder manages the Git database. So I'll do find, so I'll say find.git objects. Okay, what did I misspell here? Maybe I need to get out. Okay, I think I'm supposed to get out of the yeah. So when you look at these, this one is gonna be different from the previous file, because the database is empty and there's nothing into the database. But you can see Git already initialized created some two folders. We have the pack and we have the info folder already created for us. So the two subfolders, so for us to be able to see the objects, besides this one just gave us the contents that exist within the objects, that is the pack and the info. But if we really want to see the content within the database, then we'll use this command, almost similar, but we'll follow it with the type option and F. And as you can see, we have nothing. So this one is different from, if you can compare this one to the one that we've already done the plumbing. So if I can cd into git plumbing, so so if I run the same command, you see we have objects already stored within the database. These are the contents that exist within the database, and the other one is totally empty. So hope you can see the difference. So with the git new, so we run this, if we run the same command, we see we get nothing. So basically that's the difference between a freshly initialized git file and one that already has staging and commits done. So now the next question becomes, then how do we start populating our database with stuff, staging and commits and objects and stuff? So we can create new data objects and manually store that into our Git database. So at this point, I want you to have one thing in mind, that when you create commits are stored separately as a file, and they're stored as a blob into the database. When you create a tree or a version, it's also stored differently as a file. And what else am I forgetting? There's one thing I'm forgetting. So you have like three things stored differently. They are not stored as one. All right. So yeah, so that even the names of the files, they are stored differently. So there's a way Git comes goes ahead to, in future, it knows how it links up everything and gives you all the information that you need. So let's see how now you can create the data objects for the commits and the tree, all these objects, and store them into the database. So so I'll do an example of a very simple object. Let's say you want to store some content into the database, and I want to keep this git new fresh. I don't want to mess with it, so I'll move into the git plumbing that I'm going to mess around with it. All right. So I'll create some content. For illustration purposes, maybe let me just get back and use git new. So all right, so there we are, and from the previous command you realize that we don't have anything stored into the database. Now we want to store the very first thing into the database, and this is what you're going to store. Why do I feel like I should all right. All right, it won't do us any harm. So let's create the very first. We just want to store some content into the database. The simplest way to do is, let's say this is our test content. Oops. All right, so we'll pipe this one into a command. So if you want to write anything into the Git database, what you do, you use this command git hash object, and then we use the W option, which is to write, and then because we are passing in the standard input, so we pass in that option. So this will write this content into the database, and we press enter. So this is the most important command here is the git hash. This is a plumbing command, the very first. git hash object, and you pass in the options. So we'll be using it for a number of things going into the future. So it's just good that you know, you get to note this command and master it if possible. So we already have this content. You can see this is the hash value of this content. It's already stored into the database. So if you want to view this, so this a SHA-1 hash value, and from the previous discussions we had is that this SHA-1 hash key has got two parts. It's got a head, and that's attached to it's got a section of 38 the 38 characters represent the content that you want to store. In this case, this is the test content, and then the remaining two characters represent the header. So we have like two characters that represent the header, and the 38 characters that represent the content that you're storing into the database. So with these two combination, it then tells us clearly that at no point will you get a similar hash value. It will always be different, especially when it is passed through a digest. And we'll be able to see how that works maybe by the end of this video. So using this hash value, which is like the key, we can be able to read the content of the content contained within the hash value. And another thing just to mention is the content is also zipped in some way. So zipped, so this hash value contains zipped content, but Git has got a way of unzipping the content and separating it from the header and enabling us to be able to view the content. So if we want to if you want to view the content, then we'll use there's a git command you're going to use, and that is we'll use if I can't remember, that is git what. First of all, let us confirm that it exists within the database, and for us we'll use this command. So we find that it does exist. So here's the hash value. Now there are two interesting things here before we go ahead to reading the value, just to prove that it is the one. When you have a look at the hash value, you see the first two characters are being used to like create a folder for a folder, and then the remainder, which is 33 blah blah, now create a file that actually stores this content. So this content is stored within this file and this file coexists within this folder. So the hash value is used for that purpose. So it is split. The first two I used to create a folder, and I said the first two are like the header and the rest for the content. So what I was just explaining before. So I hope you have a clear image of what I'm talking about. So we only have that content stored in our database. So for us to view this content, there's a command. I think we touched on this some time back. We call the git cat file. And with the git cat file, you can pass in different options of flags. You can pass in T if you want to view the type of content it is, or you can pass in something like P if you want to pretty print the content. That is the P option enables you to view, determine. Git is able to use the P option to like determine what type of content it is and then print it well. And some other more options, you can just like do git help and be able to play around with that, but these are the ones that we'll mostly use. So for us to view the contents, then what you're going to do is we'll do git cat file, and if you want to see what type it is, I said this content is stored as a blob, so we'll just collect this hash value. So you can see it's a blob. Now we want to view the contents of it. So for us to view the contents of it, we'll use the p option. So we can pass in the p option, and you can see this is the test content, exactly similar to this what we entered. So that has been stored within Git database, which is awesome. So we can so up to this point you can create an object, or you can have your content, whatever form of content. It can be an image, it can be in this case it's just a text value, and you can store it into Git. Now you want to go ahead and instead of just storing this content as text as it is, what about we create we store it into a file? Yeah, so we are going to like generate a file and store it into a file, and along the same line, let's have something like a file and a way to version that file. So I don't know if I should clear this. Let me just clear this because I might use it. So maybe the best thing to do is okay, no problem. So all right, so let's have like let's create some other content. So we'll create some content. Maybe we store it in a file we call text1.txt and text2, stuff like that. So we'll have like, let's create this. We can use the echo command. Say this is the first version, and we're going to like store it into file. Maybe call it let's say versioning.txt. So we've stored it into that file, and so to be able to write it into a database, if you can remember, we used the hash object. So we'll use git hash object. Remember to pass in the right flag, and what you're going to do is pass in the file name, and in this case the file name is versioning.txt. So we have this new hash value created, and you remember I said that the first two will be used to create a folder for storing this content, and then the second one now will store whatever content you have, which is this, into this file, right? This will form the file name. Okay, so if now I can go back and view the contents of our database. So objects, so you see we have two objects already in existence. So this was the very first one we created, and then this is the second one. So up to this point, I think everything is going on well. So we've just created some content in form of blobs. So most of the stuff you do in Git is always converted into a blob. A blob is a binary large object level. Yeah. So what happens if we delete the file? So let's see the contents of this file. So we have this file created, versioning.txt. We can easily recover this file just in case we deleted it. So I just want to demo to you that if we delete this file, we've not lost everything. We still have a backup, and we can be able to like create another file and store this content into it. So for that case, let's say I just remove this file. So it is versioning.txt. It it is gone. So when we check, we have nothing. But remember, we have this hash value which has the content stored. So if you want to retrieve that, we can simply do something like this. So we can cut the content of that file. You can read the content of that file. So in this case, this hash value, and then we can write it into another file. Maybe let's call it versioning2.txt. The same file, but only that we've renamed it. So we have that. So if we view the contents of versioning.txt, you'll get that this is the first version. You can see the content is the same, right? All right. So that's it. And okay. So good progress up to that point. So that's, you can see we already have versions, and we can mess around and be able to retrieve the same data. Yeah, so we could also use cut instead of less. So should be able to give you the same results for those ones who are new to Linux. The cut command, in fact, it is much more elegant than the less command. And then all right, so that's what we have to this point. So we have the first version of our file. What about if so up to this point you can create your own content and or blob and store it into the Git database. So I believe this video has taken quite a while, and this time round I don't want to record videos that take more than 35 minutes, and for that purpose we are going to stop here. And so what you're going to look at next is we're going to break down the hash. In fact, we're going to look at how Git creates the hash value for each object that it stores into the Git database. We're going to break it down so that you're going to have a clear understanding of what really goes on. So see you next. Peace.